So let us come back on the topic. Okay, so we are dealing with the keyword. Okay, so now the genres and the keywords are converted. You can see like before the keywords in this form, and now they are converted to a very plot. So now we will see about the overview. So as you can see, it's basically a string. So we can convert it into the list. So with the list, actually what we are going to do after conversion of all this, we are basically clubbing all the genres, keywords, overview, cast, and crew together to have them in a
Hello.
yeah.
Is the screen shared because I'm not able to see the screen?
I don't know. But it was not. Sorry. Is it visible now?
Yes, it is visible.
Okay. So in the previous meet, we are done with the keywords. So I basically showed this. I hope you are able to see the difference with the made. And now I'm going for the overview. So what I'm trying to say is that this overview column is basically a string. So we can convert it into a list so that all of the columns are in list data frame itself. So for that, so we can use the lambda function. So it is now converted to a list. Everyone know about the lambda function? Okay, I will revisit it. So basically, lambda function is like an implicit way to declare a function. So by using the keyword def, wait, one second. Okay, so by using the keyword def, we basically give a explicit explanation about the function that we are making. Like in this function, we are converting something. We are basically using a for loop inside it. But this is the implicit way to define a function. So lambda is a keyword, and then x is the object that we are given as the input, and then x dot split is something that we are getting as the output. So it is basically a one-line function in which we have the argument and the return statement itself. So this gives us the list for the overview. So we are going to store it in the previous overview column. Okay, it's that now. Let us see the cast. So cast is a very huge column in itself. Like every movie has a huge number of actors that are working in, and we are going to only use some significant amount of actors. So we can use the top five actors. So the good thing about this data is like they have mentioned all the actors according to their importance in the movie. So we can take the top five entries in itself and then we can use them. So we will again, let me clear this one. So we will again make a helper function. So convert cast and then we pass object. Okay. Okay. So for using the top five vectors, we can basically maintain a counter. If counter is not equal to 5, we are going to assign it and then we will increase the counter. I hope this function is clear. So what I basically try to do is we basically build a empty list and then we maintain a counter. And then if the counter is not equal to 5, then we are appending the list, the name of the actor in the list, and then we are increasing the counter. And if the counter reached 5, we basically break out because we don't want to iterate over all the actors because it will take a lot of time. So now we are going to apply. It will take some time to. Okay, so here we go. So these are the names that we have for the actors. Like this is the Johnny Depp. I hope I refer correctly. Let's move ahead. We are going to see now. Okay, so in the crew, we don't have all the things in one place. So we have to try to make a function that fetch some names that are required. So I guess director is one person that we really care about. And we can also have a writer. Let me see if writer is a huge, yes, we have to, yeah, we have the writer and we have the director. we will try to make a function for crew also. Let's name it convert crew, and then the basic foundation is same. In this time, we can't have a counter. So what I'm trying to do is we just want the director. So if I draw first, then we are going to append it. There is no counter. So the semicolon here. Okay, so if I job is writer, then we are also going to append it. Okay, and after this, we are going to make. So, oh, we are not yet stored the card. Okay, so movie card is not saved, and now we will apply the same function for the crew. Let me make some sense. Let crew now also crew, and I think we are done. It will take some time to run. So I hope this function is clear. We are basically using the same function repeatedly. So these are the two names. Like the James Cameron is the writer and the director, both are same. And in many of the columns, the writer is not present. Just a second. Second value for the lecture. Maybe the writer is very constant. Simply write. Okay, so what is happening? The dataset contains writer in the name of two places. Like somewhere there is written as screenplay, and somewhere it is written as the writer itself. So I think we can drop this for now. It's not going to make much effect on our model. So we will only have the director for now. Or we can also use the any one. Like we are not going to read ahead if we get a director. It will take some time. Yeah. So we have the director for every movie, and now we are going to store it in the field. So let's finally see our data, how it is movie. Okay. So now we are having the title, genres in the form of list, keywords as the list, overview also in the form of list, and then we have the cast and the crew. So in the crew, we have only selected the director, and in the cast, we are only limited to the five actors, the top five actors. So I think there are spaces in the list, so we can try to remove the spaces for now. Okay. So before that, let's append all of this into a one new column and name it as a tag. So maybe tag and then we have then we will have the genre. Now, then there are keywords, and then basically all the other columns. So star, then
There is an extra bracket before tags.
yeah, thanks for writing. Okay. We are basically trying to append it. Mm. Okay. Mm. Keywords. Star. Okay, so it is saying that we can only convert the list, not string. Okay, then I don't know, guys. I'm making a mistake for the keyword for the movie. Cast is also. Is there anything that you guys are seeing? There's no spelling mistake, I guess. This is list only. Okay. Okay. Okay, let's try to do it one more. Okay. Okay. Let's say review. It is working fine. And then we have the keyword. It is also working. Okay. As you can see, there is a tag column here. It is working fine. So we are adding another card. Okay, so there is some problem with the card. Okay, we are not yet converted. Okay. Hmm. We are done with it. Why this? Let me jump this whole part. This is overview. Hmm. Okay. So now the cast is also formed. Okay, guys, now we are having the cast. I think I have not run a cell. Sorry about. Okay, now we have the text column. I hope you everyone can see. Let me bring in a function. Just a second. Yeah. Okay. So in the text column, now we have a list. So basically, it's a story, and then we have appended all the names. Like this is the director, and then these are the five actors, and then these are some keywords, and, and then there are genres like fantasy, adventure, science fiction. So these are the keywords, and yeah, the movie is at the so you can basically make a guess about the genre. So now what we are trying to do is basically we will try to get rid of the spaces, and then we will try to remove the stop words and vectorize the whole. So let's try to get rid of the spaces. So we can write a simple lambda function for it. Movies, genre. So what this function will do is basically take all the spaces here and then replace it with nothing. So we don't want any space because if you say like there is a science fiction and there is a science document, these are two both like these both genres are basically very different. But if we don't remove these spaces, then the science word is common in both the genres. In, maybe the model will fail to detect whether it is from the science fiction and then whether it is from the science documentary. And maybe it can recommend a science documentary to a person who is willing to see the science fiction, and the model will perform very vaguely in that case. So we will remove that. So okay, I basically not completed the first one. Yeah, we will copy it, and then we will make it the same thing for all the, like, the keywords. The cast also, and the so let's now see our data. Dot head. Okay. So as you can see, if there is any space, we are now free from any space within the word. So the science fiction is basically science fiction in a single term. James Cameron, it is also in single term. So there are no spaces. So now the model will clearly see which James Cameron we are trying to detect. So do it will not fall in the trap of seeing a James in this thing and the other James. Like there is Sam Mendes and there is Sam Worthington. So maybe the model will predict these two stems as same if there are spaces. Now we are free from spaces, so it will treat these two as the state different entities, as it don't know the. So I guess yes, I will not be able to make the model for now. Like we are running out of time. We only have 7. So is there any doubt? I'm free for that. Like I'm not going to take another session for now. If there are any doubts, you can ask me. Or if there are any doubts from the tutorial that I've shared, like there are 3 videos, I guess. One is a playlist and 2 are the videos. I've sent them before. I guess you guys have a look on that. So if there are any doubts from that, we can have that also. And in the next session, I will complete this model and we will also be jumping on the development part of it. And then we are going to uh, then we are going to roll down the teams for you guys. So if there are any doubts, we are open for that. Okay, I guess there is no doubt. So what is going to happen after it? I'm going to roll down a form in which you guys have to try to find out 2 data sets. One is on collaborative filtering and one is on content-based filtering. I guess content-based filtering is now very much clear as of now. I basically try to give this. uh, Just give me. Okay. So we basically try to have this model for now. Like we will have a function that will recommend the movies for now. It is based on the KNN approach only. So yeah, so we are done till here. We have included all the columns in one column, that is the text. And now what we are going to do is we basically try to find vectors for each of the movies, and then we use some of the neural network library. Like it is the NLTK library, but that is used in natural language processing, and we will use that to make the cosine similarity vectors, and then we use the cosine similarity matrix to basically find the distance between the any two movies, and then we are done with the model. So I don't think I'm going to be able to finish it now. Okay, so let's talk about the logistics. So after this, you are getting a form. You have to find 2 datasets, one on collaborative filtering and one on the content-based filtering. Then we are going to select some of the datasets from those datasets, and then we will be making teams of you guys in which you have to work on these datasets and make a content-based filtering product. I am also I will also try to jump on the web development part in the next session. So we are pretty much good with the basics of the web development and the recommendation system on content-based filtering. From the next week, we will basically focus on the collaborative filtering, and then the last week I will focus on the neural collaborative filtering, and then we are done with the project after you guys submit the final assignment, in which you guys are working in the team and making a final product for the Suggesteria, and then we are going to post it on the Heroku website. I hope the logistics are clear. Okay, that's all. If there is any doubt, okay, I will read the chat one. Okay, you guys can read. If anyone has any doubt, you can speak out.
Like we have to find each data, like one each for collaborators, Pandira.
One for the
Collaborators
collaborative
and
filtering.
content based.
Yeah,
Yeah, so apart from what you have given, like in movie recommendation system, we can find others like that.
yeah, you can find others or movie recommendation system also. Like it is a TMDB 5000 movie data, but there are 50,000 movie data. Like my GPU is not that much efficient that it can handle that much amount of data. If you are willing to work with that data, you can find that also, or you can find the other attributes about the movies itself. Like we are not included the ratings or the other things. You can also play with this. Like the TMDB also contains the budget and the other columns. I have already talked about them, so you can also work with them. I hope I am clear. And the collaborative
Okay,
filtering,
okay.
I will share a dataset for the collaborative filtering. So it will be a sample dataset, or I will record a small session in which I will be basically covering the collaborative filtering part. So I hope after that you have a basic idea about both.
Yeah, okay.
Okay. Anyone else?
Who can you mark my attendance?
Yeah. Deepak, right? Okay, then. Anyone else? Okay, I think we are good to go. So bye, guys.